So I want to look further at, if this is my periodic table and these are my columns, okay, why do these elements behave like each other in the same column or the same group, same family? And actually it has to do with electrons. And I think when we talked about how an atom is structured, so for instance, I'm going to make 6 protons here, and if you look up atomic number 6, that's going to be a carbon atom, and I'm going to go ahead and give it 6 neutrons. 4, 5, like that, 6 neutrons. And if this is neutral, I need, for every proton I have, I need to have the same number of electrons in a cloud outside. So since I have 6 protons, I'm going to give it 6 electrons. 1, 2, 3, 4, 5, 6. Cool. Okay, so that's important. So kind of think of, as we look at the atomic number for an element, the number of protons, that's also, if the atom is neutral, the number of electrons. I mention that because it's all about electrons, how we kind of have this same chemical property within the same group. So when we talked about electrons, remember, beginning with the Bohr version of what an atom is, we actually have electrons that electrons are differentiated by actually existing at different energy levels. So that's important. So electrons around the set of electrons, like that carbon atom, the set of electrons, and actually we can pick on carbon down here. Here we have carbon. It has 6 protons in its nucleus, has 6 electrons buzzing outside. But now those 6 electrons can be differentiated. I don't know if you guys can see, I see a number 2 here. And those are like what we call the inner electrons. And then we have a number 4 here. And that number 4 is the outer electrons. Outer electrons. Yeah. And if we pick on carbon, what group is carbon in? It is in 4A. So the group number for the A elements, or for the main group elements, the group number is the number of outer electrons. And we're going to call outer electrons something we call valence electrons. There, that's all I wanted to say on this slide. Okay, so valence electrons are as electrons are differentiated by energy level, they are physically the outermost electrons. So let's kind of double check, make sure that this is working for us. The group number then is the number of valence electrons. Let's pick on 7A. 7A, remember, you're going to have to know the name for those are the halogens. So 7A, if we look at fluorine and we look at chlorine, notice that fluorine needs to have 9 electrons because it's got 9 protons, and chlorine needs to have 17 electrons because it has 17 protons in its nucleus. But in both cases, if you look at the outer electrons, it's got 7, which is what it should because it's group 7A. See how that works? And the thing about the electrons is it gives the atom its, how do I say, it gives the, I guess I need to go one more. It gives the atom how it's going to play with other atoms. It's all about electrons. If an atom A is going to connect up with atom B, well, it depends on what their electrons are doing.